Jai Hind to all. Myself Yogen Narayan Prajapati, Assistant Professor at Ajay Kumar Garg Engineering College, Ghaziabad. Dear student, today I am going to teach minimization of the DFA. This topic is connected to with the university examination and also the GATE examination and other competitive examination. Now, before the minimization, first we basic understanding of the DFA. DFA contained the 5 tuples, as you everyone know, that is the Q is the set of state, sigma is a set of alphabets or a set of input that may be A, B or 0, 1 or and so on. Now, this is the known as the transition function of the DFA. It is known as the, here is a, now where Q is a sigma. Now, this one is the initial state, or we can say that this is the final state. F is a set of the final state. Now, this is the basic definition of the DFA, deterministic. The deterministic finite automata, with the help of the single input, machine can move on a single state. It means path is defined. That machine is known as the deterministic finite automata. And DFA is a complete machine. It means on every state, for the every input, transition function are available, then that machine is known as the deterministic finite automata. Or any machine that can accept the regular language, that machine we can also say that the deterministic finite automata. So, it means there are the n number of definition of the finite automata, but this is the mathematical definition of the finite automata. Now, we move on the deterministic finite automata. Minimization. First, we check this given problem is DFA or not. This is the complete machine and path is defined. There are 2 important things for the DFA. It means for this state, A and B transition are given. On every state, if all transition are available, then that machine is known as the deterministic finite automata. So, on every state, we can check the all transition are A, B transition are given. So, we conclude that this is the finite automata. So, when we are minimize the any finite automata, we follow the few steps. The first step, draw the transition table of this finite automata. What is the transition table? On Q0, A input, we move on Q1. On Q0, B input, we move from the Q2 state. Similarly, we can draw all the transition table. On Q1, A input, we move from the Q2. On Q1, from with the help of B input, we move from the Q3 state. This is the first step. Now, step 2. All these states divided into the 2 sets. Two set. The first set, the set of non-final state. Set of all non-final state. That is the set 1, and in set 2, set of the final state. This is the step 2. All states are divided into the 2 sets, set of final state and set of non-final state. It means what are the final state? That is the Q0, Q1, Q2, Q3, Q4, that are the set 1, Q4 and Q5 and Q6 are the final state. This is the non-final and this is the final state. That is the step 2. Now, we move from the another step, that is the step 3. In step 3, we check the transition function of all state. If n number of state follow the same behavior, then lie into the same set. If n number of state follow the different transition function, then it is lie into the different set. Now, this process is continue until last 2 iteration are same. Now, we check the transition function of, that is the set 1. Now, this is the set 2. Transition function of Q0 and we check the transition function of the Q1. Now, on K, that is the lie Q1, that is lie into the same Q1 1 set, Q2 again set 1, Q3 again set 1 and again set 1. It means these two state have this similar behavior. For A transition, it is lie into the set 1. For the B transition, it is lie into the set 1. It means these two sets can be minimized and lie into the same set. Furthermore, we check the transition function of Q2. Q4 again lie into the set 1 and Q6, that is the set number 2. It means Q2 have the different behavior because it lie into the Q6 in set 2. Okay. Now, Q3, that is the set 1 or now set 2. It means Q2 and Q3 have the similar behavior. It lie from the A transition in set 1 and from the B transition is lie into the set 2. Similar behavior. It means Q2 and Q3 have this lie into the same set. We move another state, that is the Q4. Q3 is 1 and that is the set 2. It means Q2, Q3 and Q4 have the similar behavior. It means these three states Q2, Q3 and Q4 have the similar behavior. Now, we check the Q5. Now, Q5, that is the set 2. Now, that is the set 2. Now, here is a set 2 and that set 2. It means Q5 and Q6 have the similar behavior. It lie into the same set. So, now what is the next state? We move from the I1. It means Q0, Q1, Q0, Q1 have the similar behavior, lie into the same set. Q0, Q1 and Q2, Q3, Q4 have the similar behavior, so lie into the same set, and Q5 and Q6 have a similar behavior, so lie into the same set. Now, how many sets? Set 1, set 2 and now this is the set 3 and we repeat this process and check the, again checking the, if all have the similar behavior, then lie into the same set. If have a different behavior, then lie into the different set. Now Q0, that is Q1, lie into this set. Now Q1 lie into the set 1, and here Q2, Q2 is a, that is the set 2. Q2 here is a set 2 and Q3 here again set 2. It means Q0, Q1 have the different behavior. It means that these two states does not lie into the same set. Now that is the I2, here Q0 have a different behavior, Q1 have a different behavior. So lie into the different set. Now check the Q3, Q2 and Q4. Now Q3, that is Q4, that is in set 2, and here is a, that is the set 3, Q5. Q4, that is set 2, now that is the set 3. And Q4, that is again set 2, and now this is the set 3. It means these three states have the similar behavior, so lie into the same set. That is Q2, Q3 and Q4 have the similar behavior, so lie into the same set. Now check Q5 and Q6. Now it is the set 3. Now again it is set 3. Here is also set, lie into the set 3. Here lie into the set 3. It means Q5 and Q6 also have the same behavior, so it is lie into the Q5 and Q6. Now move from the next iteration. All set, if all state have the similar behavior, then lie into the same set. If lie the different behavior, then lie into the different set. If last two iterations are same, then that is your final answer. And these three states are minimized into a single state. Now that is the set 1, set 2, set 3 and here is a set 4. No need to check because it is the smallest one. So now Q0, Q1 need to check this one. Q2, Q2 is Q4, that is lie into the third set. Q6, that is lie into the fourth set. Q4 lie again into the third set, or here is lie into the fourth set. Q3 again lie into the third set and here lie into the fourth set. It means these three sets again minimize, that is Q2, Q3 and Q4. Again check this one. Here lie into the 4 set, here lie into the 4 set and here lies 4 set and here is lie into the 4 set. It means these two sets are lie into the same. If last two iterations are same, now this one is the final answer. It means Q2, Q3, Q4 minimize into a single state. Q5, Q6 minimize into a single state and Q1, Q2 are the different set. It means here total 1, 2, 3, 4, 5, 6, 7 state are minimized. The state 1, 2, 3 and 4. It means total 7 state minimize into the 4 state. This is the concept of the minimization of the finite automata. Now, for the better understanding, we take another example for better understanding for the minimization of the finite automata. This one, same procedure. Step 1, draw the transition table which is already given. Now the second step, all these states are divided into the two sets, set of final state and set of non-final state. Now here is a Q3 and here is a Q3 and Q4 are the final state. So now here is a Q3 and Q4 in a one set. Now another set, that is Q0, Q1, Q2, Q5 and Q6. That is the set 1, and now this is the set 2, that is the I0. And check the transition function or check the behavior of the all state. It all n number of state have the same behavior, then it is lie into the same set. Now we check Q0, Q1, Q2. Q0, that is the Q1, it is Q1, that is the set 1. Q2 again, that is the set 1. Q4, that is the set Q4 set 2. Q3, that is the set 2. Now for this Q4, that is set 2, now here set 2. Q3, that is the Q5, that is set 1. Q6, that is set 1. Q4, that is Q7. Here mention also the another state, that is Q7. Q7, that is set 1. Q6, that is set 1. Q3, that is set 2. Q6, that is set 1. Q6, that is set 1, that is set 1. Q4, that is set 2. Now that is Q6, that is 1. To check n number of state, which number of state have this similar behavior. Now 1 and 2. 1 and 2, any state 1 and 2? No, it means I1, that is Q0 is a single state, and Q1 and Q2. Q1 and Q2 have the similar behavior. Set 2, set 2, set 2, it means it is lie into the same set. And Q3 and Q4, again we check here, lie into the Q3 and Q4 have the similar behavior. Q3 and Q4 have a similar behavior, so lie into the same set. Remaining set, that is the Q5, Q6. Q5, Q6 and Q7 have the similar behavior. That is Q5, Q6 and Q7 have the similar, because here is a 2, 2, 2, 1, 1, 1. So now this are lie into the same set. We move, that is set 1, that is set 2, that is set 3, that is set 4. And we again check. If n number of state have this similar behavior, then lie into the same set. If a different behavior, then lie into the different set. Now no need to check Q naught, because it is single state, it is not further minimized. So now that is the Q naught, we need to check Q1 and Q2. Q4, that is Q4 lie into the set 4, and Q3, that is lie set 4, that is here 4 and 4. It means Q1 and Q2 again have the similar behavior. Q1 and Q2 have the similar behavior, so lie into the same set. Now we move from the Q5, Q6, Q7. Q5 that is Q3 that is the set 4, and Q6 that is the 3. Q6 it means it is lie into the set number 3, and here lie into the set number the 3. And Q7 that is the set number 4, and Q6 set number 3. It means Q5 and Q6 have this similar behavior. Now Q5 and Q7 have the similar behavior, and Q6 have a different behavior. So lie into the different set. And Q3 and Q4, check. Q5 that is the set 3, and Q6 again 3 and 3, and Q7 here is a 3. It means Q3 and Q4 again similar behavior, so it is lie into the same set. Now this is known as this third iteration. First, second, third iteration. Now we move from the another iteration. If last two iterations are same, then that is the final answer. Now that is known as the I3. No need to minimize here. Again that is set 1, 2, 3, 4 and 5. Now Q1 and Q2. We check Q1 or Q2 lie into the similar behavior, then lie into the same set. If it is have a different behavior, then we move from the different set. Now Q1 and Q2, 4, it means that is the 4, I think it is lie into the set 5, yes, set 5. Q3 again here is 5 and 5. It means Q1 or Q2 have a similar behavior, then lie into the same set. Q5 and Q7. Q5 and Q7. Q3 and Q4, it means that is the set 5 and set 5. Or here is a Q6, set 4 and set 4. It means Q5 and Q6 again follow the similar behavior, so lie into the same set. No need to check. And Q3 and Q4. If last two iterations are same, now this is the final answer. How many state? That state 1, state 2, state 3, state 4 or state 5. It means total 8 states are minimized into the 5 state. So this is the procedure by which any finite automata are minimized into a minimum states. For the better understanding, we move another problem. So thank you. For the better understanding, we move from the take another example to the next lecture.